like how is data distributed? The shape, and is it symmetric is the main word or the main term you will use. And we look at distributions based on, sorry about the pledge in the middle, based on histograms and based on box and whisker plots. Okay, so you see right here 3 examples of histograms. Okay, well, on this first one, you see that you have a peak, a definite peak right here, which means you have a bunch of scores right here, and then you just have a couple as you trail down to the left. Okay, so the majority are here, but you have a few stragglers, if you will. So it is negatively skewed because it's skewed left, and you have a few down here with most of them there. Here's symmetric, where it's or relatively evenly distributed, and then this one is mostly on the left side, and you have a few stragglers on the right. So we call that a positively skewed distribution, or skewed to the right, because the majority is on the left. Okay, so most of today's lesson is going to be either graphing a histogram or graphing a box and whisker plot. So this first one is a histogram. Now, if you want to pause this and actually tally them up, I'll tell you what you do. This is what I've done. I take and I go, okay, so 25 is going to go in here, 22 is going to go in here, 31 here, 25 here, and you go on and you do that for every single one. You want to pause me and do that, but I kind of cheated and I did it ahead of time, so I'm just going to fill that in. 1, 2, 3, 4. 1, 2, 1, 2, 3. This one. Okay, so the frequency is 3, 9, 7, 6, 5, 4, and 2. And as I said, if you wanted to pause this and put the rest of them there, but you should go through every single every single number and place them where they belong. Okay, so making a histogram. A histogram is similar to a bar graph, but not the same. Over here, check it out. A bar chart or bar graph, each column represents a group. It's defined by a category, maybe a variable, but with a histogram, each bar represents an interval right here. So down here, I've got intervals of 17 through 20, 21 through 24, 25 through 28, 29 through 32, 33 through 36. Notice each one is 4 numbers, 37 through 40, and 41 through 44. Now, typically, I would say you have to label your graph, your x-axis and your y-axis. Now, if you're not sure, like this one that doesn't, I have no idea what these numbers represent. It's just an example, and then you can label it frequency. But typically it's number of something. Maybe you're talking about number of students, maybe you're talking about number of whatever, but that would be what it is. For this one, I'm just going to say frequency. 6, 7, 8, 9, and then in a histogram, our bars typically touch one another. So in that first one, 17 through 20 is 3, and then 9, and then 7, 6, 5, 4, and 2. And there you have it. Now this should also be labeled too, whatever, like in this case, the intervals. Typically, what would it be? Maybe you're talking weight, maybe you're talking speeds, maybe you're talking whatever, but it should be labeled, okay? All right, so frequency or a histogram is how many items are in each interval, whereas a bar graph is going to be categories and what the amount in each category. Okay, so let's try another one of these. And this one, oh, they nicely already did this for you. They even filled out the frequency. This is your frequency table. So time spent surfing on the web in hours per day. They didn't even do the tallies. They went straight to the frequency. So 0 to 1 is 20. Holy buckets. So we go all the way up to 20 and then to 18, and it goes by 2s here, and then 2 and 1. So, oh, I did not describe the shape of the distribution. So on this first one, back in these intervals, I would say it is non-symmetric, most values on the left, and skewed right, which would be positive. Positively. Okay, whereas this one is still non-symmetric. Also skewed positively, which would be right. And I'm going to write most values on the left. Couple things here. Bar graph, you always need a title and label, just like a histogram. Bars do not touch in a bar graph, where in histograms they do. A vertical scale is frequency and vertical scale is frequency. This is category and this is numerical. So breaking it down right there, or you could have read that right there. Okay, back of that first page, box and whisker plots. All right, box and whisker plots, you probably did last year. If you didn't, you're going to get a shakedown this year. Now, a box and whisker, remember, it divides it into 25. So 25% or 1/4 of your data is from here to here, and a fourth, and a fourth, and a fourth of your data. Okay? This is always the median. This is quartile 1, and this is quartile 3. This is always your minimum value and your maximum value. We need, and they call it the 5-number summary. 1, 2, 3, 4, 5 numbers, and it summarizes your data because it kind of gives you an idea of how they're distributed. Okay, so you can talk about it's being skewed or not skewed. So if you have a couple values down here, but most of your values are here. So notice how these two are nice and tight and really close together. That just means all those data are really close together. And these are spread out, so it's going to be skewed negatively or skewed left. Symmetric would be the box. The median is perfectly in the middle of the box, and the box is equal, and the whiskers are equal. So 50-50. And this one would be positively skewed because on the right side, the positive side, it is stretched out because those numbers are kind of stretched out that way, whereas in the left, they're all really close together. Okay, the median is closer to the shorter whisker, and so on and so forth. So we're going to create a box and whisker plot, several of them actually, and we're going to talk about how they're distributed. Okay, so in here, again, there should be a label, but we don't even have a label for our numbers. We're just going to practice doing this. So we are going to practice, first of all, we have to put them in order. Okay, so I can do that really quickly if you want to pause me. So I've got 2, 2, 2, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9. Okay, so there we have that, and I'm going to go from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right. Now, to find the 5-number summary, we have to first find the middle, the median. Okay, there are 16 numbers, so 1, 2, 3, 4, 5, 6, 7, 8. Right there is our median. It's right smack dab between there, so 5.5. And then if I have 8 numbers here, my median is going to be between those two, which would be 3.5. And up here, between those two, which would be 7.5. Now my minimum, right here, and my max, right there. So all we have to do is on here, now typically I would say we can go above the number line, but there's no room up there, so we're going to go below. Not a big deal. So minimum is at 2, so I put a dot here. Your median is at 5.5, so I'm going to put a line here and add my quartiles as well, 3.5 and, 7.5, and my maximum 9. So from quartile to quartile, that is from the beginning of your box and the end, and then you connect your whiskers. Okay, and so there's your box and whisker plot. Now that one, if you see, the whiskers are the same and the box is equal where the median is, so this is very much a symmetric 2M's distribution because they're equal. Box is equal, whiskers are equal. It's very symmetric, okay, or relatively symmetric. All right, let's do the next one. Again, you can pause it, but I already have them in order on a separate sheet of paper, so I'm going to write them down quickly. We got a 2, 4, 5, 5, 6, 6, 6, 7, 7, 7, 8, 8, 8, 8, and 9, and 9. Okay, again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 numbers. So 1, 2, right there is our median. So between the two 7s, so obviously going to be 7. Here's our first quartile, which would be between 5 and 6, so 5.5. And our third quartile, going to be 8. Minimum is 2. Maximum is 9. And I can do the same amount, so 0, 1, 2, 3, 4. So again, minimum 2, put a dot there. First quartile is 5.5, then it is 7, then it is 8, then it is 9 for our max. So in this box and whisker plot, notice the left side is the whisker and the box is wider than the right side. Those are very compact, so it is skewed left, which would be negatively, most on the right side. There are more over here, that's why they're all compact. All right, and I can let you do this one down here on your own, but I'm going to go on since we are already to 12 minutes. This one will be skewed to the right or positively. We're going to do it the exact same way, starting with putting them in order. All right, so what does this mean? Remember, here's, so recall that interquartile range is the length of the box. It is also quartile 1 minus quartile 3. Or sorry, 3 minus quartile 1. Interquartile range. Okay, then outlier. Here's a big thing. An outlier is any value that lies more than 1.5 times the length of the box. So here's what we do. Data that is below quartile 1 by, so if you take the interquartile range and multiply it by 1.5 and subtract that from your first quartile, if you have points below that, it would be an outlier. If you take that same amount and add it to your third quartile, it would be an outlier, and if it's above that. So let's talk about that. Let's do this example. An outlier does not affect the shape of this distribution because you kind of don't use it, all right? So let's first put these in order. Now I've already done that somewhere, so let me get that over here. So I've got, let's see, 4, 17, 19, 20, 20, 23, 24, 26, and 28. 1, 2, 3, 4, 5, 6, 7, 8, 9 members in this population. So here's my median. Now when my median is actually one of my numbers, it no longer it no longer belongs to the top half or the bottom half. It is the boundary. So I'm not going to include it when I'm finding my quartiles. So my first quartile is going to be the median of this bottom half, not including my median. So going to be between 17 and 19, or will be 18. That's my quartile 1. And between 24 and 26, so 25, that's my quartile 3. So interquartile range is going to be 25 minus 18, which is 7. Okay, I then take 7 times 1.5 and get 10.5. Okay, so that's the number I subtract from 18, 10.5. which is going to be 7.5. So if anything is below 7.5, it is an outlier. And I add, so subtract it from, add to my third quartile, which would be 35.5. Anything above 35.5. Well, we don't have anything above 35.5, but we do have one number below 7.5. So outlier 4 is definitely an outlier. Okay, now I've done this already. I have to go by 2s. So right here we've got 2, 4, 6, 8, 10, 12, 14, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36. I think I've got it. Now, because 4 is an outlier, I put a dot there or a star. Either way, I've seen it done both ways, but you will not connect it with your whisker because it's an outlier. So you actually go to the next smallest number and you place a dot there, then your median, then your first quartile, then your median, then your third quartile, which would be 25. I'm going to make my box and whisker here, and my highest number is 28. So, now, ironically, because this is not what I would expect it to be, so I'm going to determine the outlier does not affect the shape of the distribution because we're not connected to it. So there is an outlier of 4, so the distribution. But look at the box and whisker plot. Do you see how it's still skewed to the right because the right side of the box and the right whisker is longer than the left? So skewed positively. With outlier at 4. All right? There we have it. Now, analyzing distributions. Why would we need to analyze them? We're going to talk about what this means. So, if you are analyzing your distribution, you can use statistics. So, to talk about the center. The mean or the median describe the center. So, when do you use which one? Well, if it's symmetric, we're going to use the mean. So, when it is symmetric, we're going to use the mean and to describe the center, and it is this is not there, where that's down here. Okay, because if it's not symmetric, you can't use the mean, because remember, the mean gets skewed by outliers or by it pulls it down or pulls it up. So most data is going to be skewed a little bit, so not very often you're going to use the mean, but occasionally. So here, this one's skewed to the right, this one's skewed to the left. And notice the median is here, but the mean gets pulled down, just like that. The mean gets pulled down. So when we have a skewed distribution, not symmetric, we're going to use the median to talk about the center. So we're going to talk about when it is symmetric, we use the mean and standard deviation to talk about how spread out it is. And when it is skewed, or has outliers, we use the 5-number summary. In other words, the median, median, and interquartile range to talk about the spread. All right, flip that paper over. We are almost done. Right here, this just gives you an idea. It compares what a histogram and what that box and whisker plot would look like. So as you can see, skewed right, longer on the right side, skewed left, longer on the left side. This is positive, this is negatively skewed. So down here, let's talk about, we are still going to, we have this example, which I recognize from 8th grade math. Ha! So is this skewed or is it symmetric? It is symmetric. So if it's symmetric, we're going to use our mean, which you can calculate, but I'm going to tell you one thing. It's always going to be that middle number, the mean of 20 pounds. So the center, so because the data is symmetric, the center of the data is the mean of 20 pounds, because that's number of pounds of apples that you picked. Now the spread is the standard deviation. So because this is such a small, I could get out the decimals calculator, but because it's such a small sample, I'm actually just going to do this. If 20 is my mean, these are all zeros. This is 1 away. This is 2 away. If I square them, I've got 4 plus 1 plus 1 plus 1 plus 1 plus 4, which is 8, 9, 10, 11, 12, divided by 1, 2, 3, 4, 5, 6, 7, 8, 9. Which is going to be 1 1/3, and then take the square root of it. So 12 divided by 9, and square root is 1.15. The spread is the standard deviation of 1.15 pounds of apples. And there you have it. Now, very few of them are going to be symmetric, and thank goodness for that, because calculating that standard deviation would become a bummer. All right, so take a look at the next example. This one, not symmetric. So it is not symmetric, but is it skewed positively or skewed negatively? Well, it's skewed to the right, so it's skewed positively. So our center, we have to find the median. So if I count my numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18, just making sure. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. My median is 1.5. My lower quartile, or first quartile, would be 1. And 1, 2, 3, 4, 5. Third quartile would be 3. Minimum of 0, maximum of 8. Interquartile range, 3 minus 1, so 2. Probably doesn't have any outliers. Okay, so because the data is skewed, the center is the median of 1.5 siblings, and the spread is the interquartile range, and I'll just write IQR, of 2 siblings, meaning 2 either way. 1.5 is the average, but it is 2 either way, which is kind of funny because if you go below 2, 1.5 minus 2 would be negative 0.5, so obviously nothing below there, but some things above that. Let's make a box and whisker plot. We already have our minimum, so, and we're only going to 8, so 0, 2, 4, 6, 8, sorry, 1, 2, 3, 4, 5, 6, 7, 8. Starts at 0. We got a dot here. We got a line there, a line there, a line there, and a dot at 6. And I'm going to title it Number of Siblings. There you have it. Box and whisker plot is helpful when you're viewing skewed distribution since it's constructed using the 5-number summary. We don't even need to know all the numbers because our box and whisker plot gives us those 5 numbers. All right, so your assignment is that very simple worksheet. You've got to make some histograms on the front side. Make sure you're explaining the spread, the center and the spread, based on the distribution and shape. You know, so if it's symmetric, make sure you're finding the mean and the standard deviation. If it is not symmetric, make sure you're finding the other one. Okay. All right. So, and on the back side, pretty cut and dry, laid out. We've got box and whisker plots and one that you're going to make yourself. Okay. Good luck. Come see me if you have any questions.